program to be useful, so I was always a C# person. I never really used Python for much of my career. And I remember 8 years ago, I wanted to build basically an algorithm to predict how early I needed to leave my house in order to be on time to catch a flight. And for that, I needed to basically scrape all the data from the website of the airport I lived close to. And I built that in C#. And it was a very, very big program that took a lot of time to build. And I dreaded the moment I ever had to maintain it and look at it again. A friend of mine told me, go look at Python. I was like, nah, I'm not going to learn that. No way. A couple of years later, I actually needed to do the same thing. I looked at the code and I said, I'm never going to do it again. And I decided to try Python. And probably 20 lines later, I was able to achieve the same outcome. And from then onwards, obviously, I went from looking at every single problem in the world as something you could fix with C#, and now looking at every single problem in the world being something you can fix with Python. A little bit extreme sometimes, but that's a little bit just a background on my relationship with Python. On this session today, I want to talk to you a little bit about Visual Studio Code, VS Code, how we can be productive on Python using VS Code generically, then specifically for data science, okay, how we can use it for data science in a productive way. There's a bunch of new announcements that we've done in the last couple of months, and the last one 2 days ago, and I'm going to walk you through this, through demos. And last but not least, walk you a little bit into the Azure Machine Learning services and MLOps. Let's start first with Python by the numbers. And you might have seen this before. The adoption of Python is brutal. Okay, it's not just in college, it's not just for enthusiasts, it's not just for young kids. It's probably one of the first languages that's super universal and goes everywhere. And these numbers that you see here, I'm pretty sure they're going to grow another 2% year on year. Okay. Sorry, do you want me to speak louder? Yes, absolutely. Will do. Thank you. Why is Python growing? And Python is where is it growing? Obviously, you've seen it as an app building language. We've seen it a lot with Django and Flask also on the websites or as a web platform programming language, but we definitely see it growing significantly on the data science side. And that's where you see a lot of the growth coming into. And obviously we're all here. Some of us might have used R in the past, and we've seen how quickly Python has taken over even the most hardcore R fans by basically replicating a lot of the existing libraries that R had, while at the same time providing a lot of new features that only Python can do. Now let's dig in a little bit into VS Code. Now, how many of you know VS Code or use VS Code? Show of hands. Quite a few of you. Cool. Thank you. You've seen VS Code. It has obviously built-in language support, IntelliSense. You can type in and you'll get a little bit of an advice on how that, or linting on how those functions work, or what else can you type. Debugging, obviously integration with Git or other code repositories. For me, the best thing is obviously it's free, it's cross-platform, meaning today I can be on this device, next day or next hour I can be on that device, and this is something I do very frequently. Same experience, works the same, really, really quick. Obviously, being fast and lightweight is super important for me also. I used to use Visual Studio, and Visual Studio is still an awesome IDE for very specific workloads, very high-end professional developer. For me, for a lot of the work that I do, the fact that I can just launch VS Code like that, whatever I am, and get it done is super important for me. Now, also very important is the Python extension, which is where VS Code comes into really full circle with Python. That extension, right now the Microsoft one, is the most used Python extension, is updated every month. There's a blog that follows and every month gives the updates, and the links are at the end of the slide, and you can follow along what we've seen. Now, I'll show you a little bit of where we are today with this, but if I look a year ago, I would use VS Code with Python in particular for, like, if I was doing something on Flask, no problem, for sure. For data science, I would still be leaning on either doing everything on a notebook or doing some things on Spider or other IDEs. Today, where we are today, I'm pretty comfortable on doing everything on VS Code already. And it keeps growing and growing every month. Another interesting thing that I will demo is remote development, okay? So, and one of the examples I'm going to show, I'm not going to show you WSL. WSL is the Windows subsystem for Linux. It's basically a Linux kernel that you might have heard runs inside Windows 10 machines. So basically, if you have a Windows 10, you install an Ubuntu or any other distribution that's supported, and you basically just open a shell, and then you have a bash shell on that micro container running on Windows. Because today I'm not using a Windows machine, I will use something else, which is I will use remote development on a container, on a Docker container on this machine here. And basically imagine the following scenario. You have a lot of environments, or you have a special configuration that needs to run on a specific version of Linux, spin up a container, the code automatically gets deployed, the environment that you want automatically gets deployed to that container, and you run the code from VS Code on your machine remotely on that container. I think this is better shown than talked about, so I'm going to demo all of this to you. Here's VS Code. If you have not seen before, you have extensions here. If you go, you just type Python, you'll see the Python extension. That's the one I'm talking about. If you go to the changelog, you'll see everything that's get added every other week, or sorry, every other month. Okay. Let me just give me one. Yeah, sorry. If you launch the command line, you can do a lot of work directly here from the, sorry, give me a second, I'm going to try to talk louder or move the laptop a little bit closer. If you type Python, you will have access to all the different commands that we'll be working on today, okay? The first one I'm going to show to you is just basically running a normal, just a normal program. So I have a basic plot from the matplotlib. You can just get it running locally, and you get what you would expect to see, a signed function. No big thing there. If you can, obviously you start seeing the linting and the help, obviously, going when you over the functions. Other things you can do, you can run the current file on an interactive window. That's one of the first things that's interesting. So now you actually have interactive Python running in. I can close this window. Let me open up a little bit more space. You actually have interactive Python running inside VS Code. In reality, what it's doing, as you can see, it's spinning up Jupyter Notebook, okay, in your local machine, and you basically have this code that I was running right here. Same thing, and this is a normal interactive window. So if I do import numpy snp, snp np.py, you'll see it's a normal interactive window. I can run pieces of this code also. What you expected to see, sorry, give me a second. Run selection, for instance, in the Python terminal. So I can still run it on the terminal down here. I can run it directly on the interactive window. There's a lot of work I can do in between this, either the interactive console or the command line. So, and this is really what I'm starting to see, that type of interaction that I used to have, or need a notebook, or need another IDE, now it comes full circle inside VS Code, which makes me much more productive. If I open up, obviously I have access to the plots. All the plots that I'm using, I can zoom in, zoom out. A very productive way of working directly from the IDE. Another interesting thing that we have here is obviously the variables. So you have all the variables that I'm using on this interactive console. So you can explore the variables. You can actually look at the data. And for instance, you can filter it. Let me see. I want to filter only the 0.1s. Whoops, 0.1. There you go. Those are the items. So it gives you a little bit of extra productivity features that you can do directly from the interactive window. Now, what I like about this is if you see something that you're missing, because the product group that's developing this, the Python tools for VS Code, they are so open, you can just go get engaged with them on either through the blog or on GitHub and just request a new feature. Okay, so again, every month, new features today. Very comfortable with what I see. I'm fully productive straight on VS Code, but we can keep adding and we can keep requesting more things to come into play. Now let's go into remote. As I shown you before, we were running all of this locally, right? So I'm locally on this machine. Okay, I'm going to now connect to a container. Okay, inside this machine. So a Docker container with a basically a Linux version. It's going to ask me to pick an interpreter. Just give me a second to. It will get there. I don't need this right now. Select the Python. I'm going to go here. It's full on. Okay, I'm going to run it. Hold on, sorry. Yes. And you saw, basically it created this, you don't, because it's on a container, you don't get to see obviously the matplotlib output, but it created the same image, okay? And if you don't believe me, you can see that we are not on my Mac, okay? We're on that Linux container that I was creating before. I can go back and say, oh, I want to go back to my machine, reopen locally. And if I run it again, you'll see it, I'm running on, hold on, sorry, I need to pick the right interpreter. Give me a second. And you can do, and here's the interesting thing. Right now you can do it from here, or you can just go again on the window, on the window up there and just select the interpreter, the Python interpreter from here, okay? Gonna use this one, gonna run it again. Come on. There you go. As you can see, and I'm on this machine. Okay, so these are basics that show you the beginning of where we are in terms of using productively VS Code for a lot of scenarios for which in the past I used to need other tools to complement VS Code. Now let's look a little bit into data science inside VS Code. We saw, obviously we saw a little bit about notebooks, and that's fine. But when you look at machine learning on Azure, the bigger picture that we have, and I'm sorry if the fonts might be a little bit small on the screen, we look at it from 5 layers, basically. The first one is we can look at working with pre-trained models. I'm sorry? Oh, if we can dim the spotlights. Thank you. Would it be possible? Thank you very much. Thank you. Apologies for that. So on the top layer, we're looking at pre-trained models. Okay, so what I call AI as a service. So if you want to look into a computer vision, you have a computer vision problem, you have a speech, natural language problem, you need cognitive search, you can just call an API and pass it the data and get a response either with in the case of computer vision, this object is class A, B, C, or D, so a typical classification problem. I see object X in this picture as an image detection problem. You can do all of that by calling APIs. That's kind of the pre-trained model approach. The second layer is actually building when you need to build models by yourself. You can use code as we saw before. You can use notebooks, command line, or other IDEs. Then comes the frameworks that you want to build on, and obviously we'll support any framework that you decide to build on. My preferred one today is Keras with a TensorFlow backend, but I'm seeing, for instance, PyTorch being phenomenally used, and now the FastAI library on top of PyTorch, delivering phenomenal results when it comes to ease of use and performance. Okay, and obviously then we go into the kind of the model management layers. Okay, where we'll talk about Azure Machine Learning, and at the bottom obviously we'll have basically the hardware infrastructure in which we train and run these models, which can be CPUs, GPUs, FPGAs, deployed on premises, on the cloud, on your device, on your phone, or on your IoT gateway. Now we're going to focus a little bit first on VS Code and notebooks. So the first news I want to share is that obviously we can now work very closely with notebooks inside VS Code. And the thing that was announced 2 days ago is actually we used to have to import the notebook. Now we can actually open the notebook natively inside VS Code. Okay, and we can do things like debugging of cells. We can interactively add cells either in a Python file or in the notebook itself. So there's I've shown you already a couple of these things here, but it's really, really interesting to see. So I'm going to jump straight into the demo. Okay, the first thing I want to show you is talk to you about this exact problem that I have. It's a custom vision problem. So I want to pass a picture of a picture of a plane, and I want it to tell me which airline is on that picture. Okay, simple, typical image classification problem. Okay, so this is what I did in the beginning on my laptop. I built a model on TensorFlow, and this is just the code, the inference code, basically to just go and show what's happening on that picture. So if you look at, this is the image. Okay, this is just calling the inference model. Okay, and then outputting the result, okay? Which is, and this model is super sure with 99.999% accuracy. That's a plane from Singapore Airlines, okay? So I'm gonna move back into VS Code, and and you see I have here the Python notebook. I'm gonna open it, and what you'll see after a little bit is that actually I have a similar Jupyter interface inside VS Code. Now, you might like Jupyter on a white background, and I know I like Visual Studio with a black background, so this might look a little bit different, but I promise if you turn the theme of VS Code into a white theme, this looks much, much closer to a normal Jupyter notebook. So I could run this straight down, and we'll do exactly the same thing. Okay, so that's the first thing I can do, and I can call any of these lines. You'll see here, I can rearrange them, I can insert new lines, I can still use the variables as before, as I showed before. Now, the other thing that we can use is actually to import this into a Python file. So actually, I have the Jupyter notebook, I want to import it into to a Python script. Okay, and here you have the same code. Let me just close the window to maximize a little bit. Here you have the same code fully on already as a Python file. Okay, and what you'll see here is that when I put this tag, and I'm going to put it here, the same thing. When I put these tags inside, which obviously you can see they are comments, it's just VS Code is interpreting those Python comments as something else. When I put those tags here, I can start treating that Python file as a discrete, almost like a notebooky experience. So it's halfway between a pure Python experience and a notebook. I can have like something in the middle that in the IDE behaves like a notebook, but if I take it out of the IDE, it's a normal Python file. Okay, so that's something that's actually super cool, and I'm really excited about using more recently. Trying to make sure I don't forget to demo anything to you guys today. What I can do, I can go back to the basic plot, and what I can do here, don't save. If I go here, I can do the same thing, which is I'll put this here. And I can debug the cell. So it's going to run. And it's going to show me a debug window. And there you'll see, in that, I didn't have to set a breakpoint. I could do almost like a fake breakpoint. You'll have the preds, which actually it doesn't matter. It was for another Python file, but you'll have here the local variables. Okay? And you have access to the call stack and everything that's going on. Okay, even from a debugging experience, the ability to do this, it's really, really cool. Okay. Let me go back. Now, when we look at the frameworks, and I'm going to I know we started a little bit late, apologies for that, so I'll try to accelerate a little bit. When you look at the frameworks that we support obviously the typical data science and machine learning frameworks that everybody is working on, or most people are working on, obviously. But we also did an intentional effort with Facebook and now with several other companies on building an interchangeable format called Onyx, which you can see on the right. It's picking up adoption. Obviously, it's not mainstream today, but it's picking up adoption as a really good lingua franca between the different machine learning models. Okay, and it allows us, for instance, in my case, to deploy a model that I put on Onyx that I can download from the web, deploy it immediately on very different types of devices. And that form factor is important because if today, think of like this model, Keras with a TensorFlow backend. If I want to deploy it on my phone versus this machine versus an IoT gateway, it's going to be completely different. Once the full promise of Onyx is there, I have one model converted into Onyx that can be deployed on any platform, okay? Regardless of being an edge platform, a full-on inference cluster in the cloud, or my own mobile device. So that's something we're working on with Facebook and a lot of other hardware vendors, and that we hope to see come forward as an open source and an open consortium for this, to fix kind of the proliferation of models and model management frameworks. Now, I'm going to talk a little bit about Azure Machine Learning Services, okay? And kind of the problem that we've seen so far, so that example I showed before of that inference of the airline, I built it on my laptop. I trained it on that one, which is a Surface Pro with a GeForce discrete graphics card. I deployed locally the first couple of times. It takes 15 minutes to build a model. Makes a lot of noise because all the fans start working, and I can only get an accuracy of 90%, okay? Because the file size is small. I have to make a lot of compromises to run on a machine like that. What if I had a platform, super easy to just deploy that model, take care of the training, of the data versioning, of the model versioning, of the deployment to a web service, all of that end to end, without me having to write all the code by myself, okay? And that's what I'm going to show you with Azure Machine Learning Service, okay? Again, it's basically a platform for helping you manage your data science lifecycle in a more productive way. More productive and also more collaborative, meaning, obviously, I'm submitting the code to GitHub. That code can be seen by anyone else, but also if anyone else wants to run an experiment based on my data or based on my experiment pipeline, they can do it all the same, centrally from the same repository and from the same platform. So beyond a little bit of, beyond that, the Azure Machine Learning Services also gives us several different interfaces for several different types of users. Today, I'm going to focus on notebooks again and on the SDK with VS Code, but depending on your level of proficiency with code and with data science, you could either use automated machine learning or you could use a visual interface, okay? And if you kind of look at the split, depending on whether you're a full-on data scientist or you are a full-on developer or both or neither, you will have some of the right tools for doing the right job, okay? And that full support is where we want to be at, okay? Today, as I said, I'm going to focus on the top end, Python SDK, and notebooks. So on the notebook VMs, so immediately as part of the backend from the Azure Machine Learning Services, you have access to notebook VMs, which you can provision, decide which size you want the machine to be, whether it wants to be a GPU-enabled or not a machine, whether you want it to be always running, or you want to have a pool of up to 5 VMs that start only on demand whenever someone requests one of them. You can obviously tune all of that. The good thing is that whenever someone starts a notebook on one of those VMs, immediately everything is configured. They don't have to go and mess about getting the right Conda environment or the right packages installed. It should be covering the vast majority of what's needed today. Okay, and as it gets updated, because you can pull new versions, obviously you'll get the latest versions of TensorFlow right now with 2.0, you'll get the latest versions of everything that's coming up. Same applies for the SDK. Better shown than told, so I'm going to go into the demo again. Before I go into the demo, obviously I'm going to show a lot of this, both on the UI on the web, and on VS Code. Whatever you see on the UI, which is where I'm going to start, you can also access in VS Code through the Azure Machine Learning extension for VS Code. So the first extension I showed was Python. The second one I will show a little bit is the same extension for Azure Machine Learning. Now, the scenario I'm going to walk you through is what's in there. Okay, step one, I didn't show you how I trained that model, but I showed you the inference piece on my local machine. If you remember, you can see it's running on my machine. Okay. Step two that we're going to go is we're going to go into Azure Machine Learning Studio. I'm going to show it. Then I'm going to go into another notebook, and I'm going to do the model training or show you how to do the training and the monitoring of the training process, and saving that resulting model in a central repository that's obviously version and can be shared by different people. Step number three, I'm going to take that model and I'm going to deploy it as a web service, also using Jupyter Notebooks. Last step, I'll just run inference on that model, which is what we did on the first step, but by calling the web service that I deployed through Azure Machine Learning Services. Okay, you can see the architecture on the right, or a macro architecture of what I'm trying to achieve. Okay. Cool. Let's go into ml.azure.com. Apologies if there is any glitches. The good thing of being on the preview branch is that I sometimes deploy things overnight, like they did this night. So I hope I find all the buttons in the right place and no unexpected glitches. So what you'll see here, I talked about automated machine learning, visual interfaces. We're going to focus primarily on notebooks today. Okay. Obviously, as part of a productive data science lifecycle management platform, you have your data sets, they are versioned. The idea of versioning them is basically being able to build a model based on different versions of the data, but at the same time, once the model gets deployed, understanding data drift and understanding whether we need to flow back and retrain the model based on the model performance in production as time goes by. Obviously, the experiments that I'm running at a specific point in time, I might be running several experiments. I might have many models on the same experiment. The models themselves that I built as part of those experiments, and the endpoints, which is basically just the web service endpoints that I can build based on those models to infer for inference, basically. Okay. On the management side, so this is kind of the machine learning experience. On the management side, you'll have the ability, obviously, to manage your clusters. Those are the compute clusters I have in this workspace. By the way, the macro container for this is called the workspace. It's an Azure Machine Learning workspace. You can see I have the CPU cluster has one node running. I can come in and say, you know what? I actually don't need anything running right now because I'm not training. If I do need training, I'm okay with waiting for you to spin up the machine. Okay, so now you'll see it's going to start decommissioning, resizing. Now it's resizing from 1 to 0. What this means is that before, if I wanted to run an experiment targeting that specific cluster, if I only run one, it starts immediately. If I run two, it waited for the machine to build. Right now, because I'm resizing, whatever I target that cluster will need to wait for a couple of seconds to spin up one machine. Okay, let's go into the notebooks. The first thing we're going to do is we're going to look into deploying a model. Okay, and because I believe, and you'll see here a very usual notebook experience, because I believe most folks are more give me a second to reconnect, are more used to the normal Jupyter notebook. So what I'll do, I'll just go behind the scenes, the same cluster that I'm running with the same Azure the same notebook VMs that's running. Okay, I'm just going behind the scenes, and you can see there's no magic. I'm abstracting this from you, but if you want to see the notebook itself, you can see the notebook itself, okay? The Jupyter Notebook platform. I'm going to go and look at the first way to train on a remote cluster. Remember, first I was just training locally. I didn't show you that code, but it was locally. Now I'm going to show you how to do the training remotely. Now, basically, I'm loading that workspace that I shown you before on the UI. I'm loading it. It's this one here. I'm telling which experiment I want to run this on, this particular training. And then I'm doing something interesting, which is I'm putting the training script, I'm writing locally on the file. Why? Because when I deploy this on the cluster, this is going to run, and it's going to write this code locally as the training.py, which is the file I wanted to run. It's basically, you can see it here. It's just it's a transfer learning model. It uses exception. Okay, so I'm not building this from scratch. I'm using exception, and obviously it takes 15 minutes. I'm not going to do this right now. One of the good things is that I can train this, because it's on a GPU cluster, on much bigger image sizes. So on my local machine, I was training on 71 by 71, which is the minimum for exception. Here I can do 200. So obviously the accuracy jumped once I trained the model here. And you can see here I'm building the environment for the training job. So I'm telling the cluster management tool, here's the Conda environment I need. Here's the pip packages that the Python packages that I need, and so on. Okay. I'm telling it which target to do. In this case, I told it to run on a data science VM on Azure. I'm giving it a little bit, like the training file, a little bit more information, and then it starts running. Okay. And then I can monitor on the portal while it's running, or I can monitor here, because I know the name of the run. I can do this, which is just run it here, and you can see the logs. It already ran, and if I look at the log for this specific run that I did last night, you can see that it achieved an accuracy of 0.99, 0.41. Okay, and it took 15 minutes, roughly 15 minutes to run the full process. Okay, so now I trained the model. I have a model. I actually saved it locally as part of my training file. You will see here that I saved it locally. Okay, I saved it locally in the outputs folder. So what I will do, I will just register the model. Okay, I'll take that model and I'll register it on our model registry. So it's here, and you can see it created a new version for that. Meaning it's obviously, again, data was versioned, data sets were versioned, models are versioned. A/B test comparison of data, models, everything along the way. You see the productivity that you can achieve with this, right? Now, I want to deploy this. I have a model, it's in my central repository. Now I want to deploy that as a web service, okay? So I will, again, connect to the SDK. I will open up the workspace. I will look exactly at all the models that are in there. I pick the model I want to deploy, which is the one I saved before and trained before. I'll create the Docker image for scoring for the inference piece. So basically, this is just the inference code. It's very similar to the one I did on the first notebook, if you can see. Same thing. I pass it an image of an airline, and it tells me which airline is in the picture. Okay. Again, I pass it the dependencies that I need for that specific environment to run. Okay. I'm going to tell it exactly what do I need. Probably in this case it's very basic packages. It then creates the image, the container image, and it deploys it. This step is to deploy the image in a registry, okay, in Azure Container Registry. If we go back here, it's deploying here, and then taking that registry and deploying the image as an ACI image, okay, meaning that you can get it deployed without the need for any orchestrator. If you want to deploy to Kubernetes, for instance, perfect, you can do it, okay? And the last step is to actually expose it as a web service, okay? And what you have here, it will give you a web service endpoint that if you go here, you can explore, obviously. It's here, the endpoint, okay? I'm gonna go very quickly back to VS Code because I know we're running out of time, and I'm gonna show you the code for inference, okay? So I'm taking the workspace, okay? I'm telling it exactly what's the workspace name, what's the endpoint I want to target, okay? I'm passing it the image, and if the image is this one, okay? No, that's the Emirates image, sorry. The image is this one. And if I run this, it will tell me that it's Singapore Airlines plane. There you go. Singapore Airlines, 99%. If I comment this and give it Emirates Airlines plane, just in case you don't trust that the model actually does what it says it does, it's even more sure that the other file, which is this one, is an Emirates Airlines plane, okay? Now, we are almost out of time, so I'm not going to do a demo for MLOps. I'm just going to talk a little bit about MLOps, because what we saw can be used to build MLOps or DevOps for machine learning or DevOps for data science or a little bit DataOps, okay, beyond DataOps. MLOps is a philosophy, okay? It's not a tools. It's like when you look at DevOps, you look at the people, the process, and the products or technology that enables continuous delivery of value to end users. That's the same thing we want to achieve with machine learning, okay? We want to go from iterating by ourselves in closed loops into full circles where our code gets fully managed, fully deployed, goes into production, is monitored for, again, for data drift or for any type of deviance during production, comes back, and that flow is not just within the data science lifecycle. That flow goes from data science into development teams, goes into production, then comes back, okay? I'm going to give you, I'm going to move a little bit faster, I'm sorry. So I'm going to tell you a little bit, obviously you've probably seen this before. We're connecting the rightmost two pieces, which is DevOps that we've heard of, with the machine learning lifecycle, okay? What you saw today that helps you achieve that, you saw a little bit on the Azure machine learning piece, which covers the machine learning or data science lifecycle, covers a little bit of DevOps, because I didn't show you pipelines, but you could have pipelines inside Azure machine learning. You saw the versioning. You didn't see me committing code to Git, but in the background, if you saw it on VS Code, there were already the Git button was enabled, and I was submitting the code to GitHub. What's missing here is whenever I submitted, whenever I did like a push on all of that code that I was using on VS Code, triggering a new build of something that goes into production. Okay, so that automation piece that we can achieve through Azure DevOps, it's the only piece that was missing today and that I didn't show you. Okay, I'm going to give this as reference. This is an MLOps reference architecture that we've built. The links are at the bottom. If you have several resources here, this is the QR code for you to download the deck with all the resources. I don't do a lot of social media, unfortunately, but if you just look at JOAOBI, I'm going to put it, it's in the beginning of the session. It's my email, it's my pretty much everything. Whoops. And with that, I will open up for any questions. Any questions? Yes, please.
I saw your example where you created an endpoint. You replied to an endpoint, but then after that, when you were consuming the endpoint, you had to call some workspace. You can create a workspace or a web service object.
Actually, I didn't need to. You're right. Why did I didn't need to. Why did I do that? Oh, yes. You're right. I invoked it through you're absolutely right. I invoked it through the Azure Machine Learning API, but I didn't need to do that. No.
So, by right, once the endpoint is done,
Yeah. I did. Very good question, because I was doing it inside the notebook before, and in the notebook I was using the normal SDK. So the SDK is useful for two things. Very good point. I mean, you're definitely paying attention for sure a lot to this. So the SDK is useful for managing the whole experience. You can do everything you can do on the UI, on the obviously on the SDK. Once you have the endpoint, you just need to query it like a normal endpoint. You're absolutely right. And I showed you, right? I showed you here the endpoint. It's here. Okay? You have the URI here, and you can just call it and invoke it normally. It's just that. Good point. Very good point. I was completely blindsided by doing everything. The other thing I didn't show you, obviously. Sorry, give me a second, because I promised I would show this. And it's, where is it? Do I not have it on the Mac? Any other questions? Good question. By the way, good question. You get a special.
Thank you for great talking. I have a question. Actually, I like Vim. Can I use Vim pipeine in the VS Code?
Can you use?
I like Vim. The
Vim.
Yes, VIM.
Yeah, Vim.
And
Yeah.
can I use the Vim keybind in the VS Code?
Good question. I think there's an add-in for that for sure, an extension for that for sure. I don't use it, but for sure. And if not, you can build an extension. But I'm pretty sure, like the key bindings for Vim for sure. And here's the easy thing about Visual Studio Code. You can use it the same way everywhere, but the extensions might not work the same. I mean, they work the same, but you might not have the same extensions in all deployments. So I don't know which one was first.
Just very quick one. Is the DPrep package available in annual service?
Yeah?
DPrep, the one from Workbench?
Oh, there's a data prep package, yes. Yes. Not exactly the same as before in the workbench. Okay? But there is a data prep. I didn't show you data pipelines today, but there's the data pipelining in which data prep is part. And if you go to the docs, the Microsoft docs, you'll get all the classes from the SDK, and one of them is still the old data prep.
Yeah, when you install the extensions, it showed several Python extensions there, right? So which other ones do you recommend?
Good question. So I currently use the Microsoft one, okay, because now we caught up with most of the other ones, and it's the most popular one, okay? Obviously, you're free to use whichever one you use. And what I would ask you, please, if you use any other ones that you find better than the Microsoft one, let me know, because I want to try them too, okay?
So is there any?
Was before, and I'll get back to you straight away.
Some of the apps that you use don't actually use the latest version of TensorFlow, whatever. Can you stop the update?
Good question. So I actually, because of GPU training on that specific model that I built roughly a year and a half ago, it requires very old TensorFlow, so 1.12, 1.15, and I struggle a little bit doing it on newer versions. It was not running out of the box, and I didn't have much of it. Using old carrots, but you can put the version whatever you want. Once you build the dependencies for your cluster, you can run whatever version you want.
So is there any community version for this? You can try for free sometimes to test it.
The question was there a community version? So VS Code is free. Okay, the extensions are all free. Azure Machine Learning Studio is Azure Machine Learning Services. It's an Azure service, so you can sign up and get a free trial, and you'll get credits for it, like any Azure service. Everything else I've shown here is free.
I'll get back to you. Thanks for the talk. Maybe a bit of a different cloud, like instead of Azure. Is there something like that?
If you want to move to a different cloud.
No. Yeah. So basically, if I want to convince other people in my company that we should move to Azure, it would be useful if there was also already a path in case that goes wrong, that you could go back. Is there a way to sort of whatever we built there, you could run it somewhere else? Maybe of course you would support it as a first-class citizen, but maybe sort of as an emulator that you can use. And maybe it's slow because it's not the greatest.
Good question. So whatever you saw there, like the machines, the virtual machines, you just need to give it an IP. Okay, so in theory, if you can build that connection, that VPN connection back to whatever cloud you're using, or you expose those machines to the cloud if you want to public internet, you can train them whatever you want to train, for instance. And obviously the Workbench SDK needs to run on Azure because it's a PaaS, it's a platform. Okay, but everything else, all the infrastructure pieces that you saw here, some actually work on my machine, on that physical piece of hardware. So if I try to connect to them, they will fail because it's not connected to the internet. Okay, so all the hardcore training and inference, you can run whatever you want to run. I don't advise that, but you can do it. Of course you can.
Can you talk a bit about how you keep track of data drift, so when during production you know that you need to retrace data?
Let's take that offline, please. Long topic. Okay, so yeah, I avoided a couple, not avoided, because of the size of the talk, there's a couple of very interesting points around hyperparameter tuning, around data drift that I didn't adopt today. Okay, we can take it a little bit offline. That's okay. Okay, we are super over time. Thank you very much for your time and hope it was useful to you. Thank you.